Let us now talk about this problem, stock buy and sell. We assume that we know prices of a stock for upcoming end days. And we can buy the stock on any day and then we can sell the stock in any upcoming days. We need to maximize the profit. In this example, we know the prices of stock for upcoming 5 days. And you want to maximize the profit. So what you will do, you will buy this stock on first day and then you will sell this stock second day. So you will get a profit of 4. Now you will buy it here again and sell it here again. So you will get a profit of 9. So that's how you get profit 4 plus 9, 13. That's the maximum profit you can get. You cannot get less than this. Now let's see this example. If your prices are sorted in decreasing order, then you can never get any profit. Because whatever day you buy, you have to end up selling it at lower prices. If your prices are sorted in increasing order, then you can always buy the stock on first day and sell it on the last day. Because it's increasing order, you will get the maximum profit by buying on day 1 and then selling on last day. Let us see this example. In this example, to maximize the profit, we buy it on day 1, then we sell it on day 2. We again buy it on day 4 and sell it on day 6. That's how we get the maximum profit. 5 minus 1, 4. 8 minus 1, 7. 4 plus 7, 11. Now please pause this video and try to think of a solution for this. We are going to talk about 3 different solutions for this problem. Let us now talk about naive solution to solve this problem. What we do in naive solution is we pass starting index and ending index as parameters and we write a recursive function. So for this array, our starting index is going to be 0, our ending index is going to be 4. Here I have written the values of start and end. These are the initial values we pass to this recursive function. And if start and end, they together have only one element in this range or less than one element, then we return 0 immediately. Because for a single day price, you cannot make any profit. Now if it has 2 or more elements, then what we do is, we consider every such pair I and j such that I is smaller than j and price of j is greater than price of I. So you have a pair I and j such that you can buy on day I and you can sell on day j and you can make some profit. That's the basic idea. So price of I is smaller than price of j and I also smaller than j. Once you find such a pair, you take this pair, add this pair's difference to the current profit, then you recursively call max profit for the left of I and max profit recursively for right of j. Right? So this is what we have done. We have considered every pair where starting point is considered from start to end minus 1 and ending point is considered from I plus 1 to end. We take only those pairs where price of j is greater than price of I. So j is greater than I, right? We begin from j equal to I plus 1 and price of j is also greater than price of I. For every such pair, we compute the profit that we can get with this pair. Then we recursively call for the left of I and right of j. And whatever profit we get with this pair, we store it in the current profit. We consider all such pairs, consider the current profits for every pair, and we take the maximum of all those profits. So our result profit is going to be maximum of all such profits. That's the basic idea of this recursive solution. Let's see with this example. We have start as 0 and end as 4. So this condition is not satisfied because end is greater than start. Now we run this loop. We begin with I equal to start and go till end. So our I is going to change from 0 to 3 and our j is going to change from I plus 1 to 4. So this is the first value for I and j, first pair of values for I and j. We get this profit for this current pair. And why are we considering this pair? Because price of j is greater than price of I. We would not have considered this pair if price of j was equal or smaller. So we consider this pair, find the profit with this pair as 5 minus 1, recursively call and find the profit on left of I. Left of I means I minus 1, which is minus 1 here. And then recursively find the max profit from right of j. So j is 1, so right of j is 2, and your last is end is 4. This is going to give us the maximum profit that you can get in this particular range. And maximum profit here is 9. And maximum profit on left of I is 0 because this condition is satisfied in this recursive call. So the profit that you get for the first value of I and j is 13. Now you change j for current I. For I equal to 0, we are going to consider all j's. Now you change j to 2. And what is the profit you get with j equal to 2? You are going to get 3 minus 1 profit, 2. And then max profit from 0 to minus 1. And then max profit on right of j, which is 3 to 4. So this is going to give us the profit 0, and 3 to 4 is going to give us the profit 4. So your overall profit is going to be 2 plus 0 plus 4, which is 6, which is smaller than 13. So you will not be updating the profit. You will be keeping the profit as 13. So this is how you are going to consider all those pairs I and j such that I is smaller than j and price of j is greater than price of I. So you will consider all such pairs, and for every pair you will find the profit and you will take the maximum of all such profits.